Namaste. So let us start today's class. So in this class, we are going to solve two varieties of problems. Okay. So the problem is being given over here. So we need to reduce the given block diagram. Okay. And we need to find out the transfer function of this given system. So that is the objective of this problem. Okay. We need to find out the transfer function. As we know, we already studied different types of rules we have studied. And we know what is the procedure. That means when we need to apply the different rules. Okay. So now in this problem, can you tell me how many blocks are in series? That is the step number 1. So that is the procedure, right? So procedure number 1, identify the blocks which are in series. So in this case, how many blocks are in series? So none of the blocks are in series. Now, what is the next step we can do? So we need to find out whether any blocks are in parallel. So in this condition, you please pay attention. Here G3 and this signal. So E is in parallel condition. So it's because the flow of signal is in same direction. So therefore we can mention this one, right? So these two blocks are in parallel. Next, what else I can apply? So here pay attention. Here I am having one summing point, one block G2, and there is a feedback signal, right? See, this can be taken as what? Minor feedback loop. I got this one. G2, the summing point, and there is a feedback signal is also there. Unity feedback signal. If in that signal, if nothing is there, then we need to consider what? A block which is a transfer function of 1. In the same way, here also in this signal, we have signal, but there is no block at all. So in this situation also, we need to consider a block which with the transfer function of 1. Okay. So this is what we need to do. And one more challenge is there. So we need to eliminate this summing point. So how to eliminate that summing point? So I am going to explain you all those things. Let me reduce one by one. So this can be written as what? So first I am going to write the forward part. R of this. I am going to retime this G1. Okay. I am not making any changes to that one. So here I am applying the transfer function. Here is a negative feedback loop. So, but the summing point remains. Why? So, because there is another signal which is coming to the summing point. So, just I am eliminating this minor feedback loop. So, this can be written as what? This can be written as G2 divided by 1. So, here it is a minus. So, in the formula it will become plus. It will be G2 H. What is H over here? It is 1. Okay, so next I am going to redraw this one. So here the two blocks are in parallel. Then what we need to do? We need to do the algebraic summation. For that you need to pay attention over here. What is the symbols are there? If nothing is there, so then it will be a plus. So therefore, so this will be what? G3 plus 1. Okay, so this summing point will be eliminated because these two is get combined. So next, so what we have? We have the output C of S. Now we have 10 doubts. So now I need to eliminate this summing point. How to eliminate the summing point? See, from this takeoff point. So let me name this one as summing point 1. So this is a takeoff point 1. So this is already eliminated summing point 2 and takeoff point 2. From this takeoff point T2 to this summing point 1, there is a path. So what is that path? So I have a H2. I am going to come across H2 after this summing point 3. So if nothing is there, then the symbol is plus. So after summing point 3, I have H1. So then I am going to this summing point 1. That is the path number 1. So I am going to rewrite that path. Okay. So I am having the signal. So what are the things I am going to come across? First I am going to come across a H2. My object is to eliminate this summing point so that we can easily reduce the problem. So what we have? So next we have a summing point 3. So with the symbol of plus. So instead of summing point, what I am going to do is plus 1. If there is a minus, then it will be a minus 1. So now it is a plus. So therefore I am going to write it as plus 1. Next I am writing path by path. So after the summing point, what I have? I have the h1. I have h1, block number h1. From h1 to this summing point 1 with the negative symbol. Okay, so this is the path. So this is the path from T2, that is the takeoff point, to the summing point, which is going over the summing point 3. So what else is there? So from there is a takeoff point 1. So there is another signal is there. What is that? So takeoff point 1. So I am having a summing point 3. So if I start from here, I will come across the first summing point 3 with the symbol plus is been given. So the symbol of plus 1. So after that one, h1. So then I am going to go for summing point 1. See, from takeoff point 1, summing point 3, and I can't able to go like this because the arrow is in different direction. I need to follow the path. I can't able to disengage from that path. Okay. From takeoff point 1, I am going to have a summing point 3, then h1, and go to the this summing point 1, the symbol of what? Minus. I am going to redraw that one. See. So what is the symbol for summing point 1 here? It is plus 1. I am going to write plus 1. So then I am going to come across what? h1. I am going to write h1. h1 to this summing point 1 with the symbol of what? Negative. So this is how we need to eliminate this summing point by separating the paths. Okay. So this is how I have eliminated the this summing point and has separated the paths. So what is the next step I need to do? Now I need to check whether any blocks are in series, parallel, minor feedback loop, and we need to start the procedure. So here, see, these 3 blocks are in what? Series. These 2 blocks are in series, and this is a minor feedback loop. So all these steps I can go into it the one shot. Okay. So let me write that one. Okay, so I am going to rewrite this one. So I have an R of S. First I am going to come across G1. See, I have a summing point. So as I told, so this is a minor feedback loop. As I told, you need to write the sentence for step-by-step method. So if I keep on writing everything, I can't able to cover all the problems. Okay. So here I need to write the element in the summing point. So here G of S means what? So it will be G2 divided by 1 plus G2 divided by H1. Okay. So here what we have here is a symbol minus. So it will be 1 plus G2 divided by 1 plus G2 into what? H1. So I am going to write it over here. H1. Okay, you need to simplify that one. Okay. So if you simplify this, so we can rewrite this one as G2 divided by what I can write? So G2 plus G2 H1. So I can rewrite that one as like this. So there will be 1 plus, right? So this I can write in this after simplification. So just I will erase this one. So this I am going to write as G2 divided by 1 plus G2 plus G2 H1 after simplification. Okay. So this I am going to erase this one. So next what else we have? So we have this block. So G3 plus 1, and finally we have an output E of S. So this path has been eliminated. Now these three blocks are in series. Now we need to do the multiplication of those three blocks. So it will be minus over here. So it will be what? H1 and H2 and finally the feedback path. So now it has been reduced, right? So now what is the next step? So these two blocks are in series. So we need to multiply. After that, so we are going to get the minor feedback loop, and finally we are going to get one more block, and that block and this block will be in series. Now we need to do the multiplication of it, and you are going to get the final transfer function of the system. I hope you are going to continue from here. Okay, so I would like to explain. So wherever it is required. Okay, so wherever it is required, I am going to explain such things. Okay. In this problem, so none of the blocks are in series, and don't get confused. Here G3 and G1 is not in parallel, because many of our students will get confused in this. If they are going to do the first step wrong, so they are going to get the 0 marks in their examination. So that's why please pay more attention to all those things. Here G3 and G1 is not in parallel, because why? Because there is one summing point is there between this takeoff point 1 and the summing point 1. If this summing point is not there, then we can consider these two blocks are in parallel. But in this case it is not so, my friends, because this summing point is there in between this takeoff point 1 and this summing point 1. So it will be easy for us to name this one takeoff point 1, summing point 1, takeoff summing point 2 and the takeoff point. So because it will be easy for us to explain, right? So here, as our friend has told, so here we are going to first reduce this minor feedback loop, right? So this is a minor feedback loop, and also we are going to shift this takeoff point, or else we can shift this takeoff point before the block G1. So we are going to shift the takeoff point before the block G1. Okay. So just I am going to apply the two rules: shifting takeoff point before block G1. Okay. I am going to apply these two rules. So if you are getting confused, you can go step by step. So let me write with step by step only, so you should not get confused. So summing point, so 1 I am going to retime, because I am going to do that step with afterwards. So next I have a G3, next I have a G1, here I have a summing point. Okay. Now I am going to eliminate this one by applying the formula. So this can be written as G2 divided by 1 plus, y plus, minus is here, so G2 H1. Okay, so next it will be what? So output C of S, and what we have, so here we have a negative, and this is the H2. Okay, and that's the takeoff. So this is what, after applying the minor feedback loop. So what the next step I am going to apply is, try to shift as per the procedure, try to shift the summing point as much as possible towards the left side. If you go step by step, so it will be easy for us to solve the problem. So that's why what I am doing is shifting the summing point to before the block G1. Okay, so shifting the summing point before the block G1. So then what I need to do, I need to add the same block, right? I need to add a same block to this one, or reciprocal of that one. So what we have to do? I think we need to add a reciprocal of right? We need to add the reciprocal of that block. So this can be reduced to, I am going to redraw this one. Okay, I am going to first come across the summing point 1, right? Summing point 1. So what I am doing is I am shifting this, take out summing point 2 before the block. See, I am shifting this signal. So therefore, so here, so there is a 1 by G3 will be there. It will be there. So I have shifted the summing point 2. So this is the signal. So here what I need to add the block? I need to add a block. So G3 will be there. So here I am going to add a reciprocal of that block as per the rules. Please refer the rules. So next, what we have? So we have a G1. Next, what we have? We have G2, 1 by G2, H1, and finally C of S. And what else here to this summing point 1? So we have a feedback signal of minus H2. Okay, so this is the changes. Please pay attention. Shifting the summing point to before the block G1. So just I am going with the procedure rules. Okay, is it right? Any doubts over here? Any doubts? So what is the next step? So next one is we need to add these two blocks. We need to multiply these two blocks. Why? Because it is in series. So this block G1 and this block are in series. Apart from that, what else we can apply the rules? In your rules apply manbodu. Please let me know. Anyone wants to answer for this? Please try to answer. So we are going to apply two rules, right? So this rule, these two are in series. We are going to do the multiplication. Next step? What summing point 1 and summing point 2 are in series. And none of the blocks are in the in between. There is no blocks at all. So what we can do is we are going to apply the rule number 1. What is rule number 1? Associative law. If the summing points are there without any blocks in between, we can interchange the summing points. So we are going to apply the rule over here. We are going to apply the associative law. So we are going to interchange the summing point 1 and summing point 2. So then I am going to rewrite this one. This is the R of S. This is an input. So I am going to get the. So this is written as what? G. What is this? G2, right? So this is the. This one is the 1 by G2. So it will be G3 by G2. Okay. So G3 by G2. So just I am going to interchange that one. So therefore I am going to get the summing point 2 first. So next I am going to have a summing point 1. So this is summing point 1 with the symbol of what? Negative. So then I am going to do the multiplication of these two. So it will be G1 G2 divided by 1 plus G2 H1. So output is C of S. So next, so we have a log over here H2. So this is what we are going to apply the associative law. We are going to interchange the summing point 1 and summing point 2. So please pay attention. This is summing point 1 and this is the summing point 1. This is 2 and this one is 1. So now what else we are going to apply now here? See here. So this block and this signal. So the two are in parallel. If nothing is there, we are going to consider this one as what? 1. So these two are in parallel. So next, this is a minor feedback loop. So after reducing this step and this step, we are going to get the two separate blocks. That two blocks will be in series. So if the two blocks are in series, we are going to do the multiplication of those two. Okay. So then we are going to arrive at the final transfer function. I hope you understood this problem. Thank you. Namaste.